The first thing that when we talk about pseudo force should come to your mind is the meaning of the word pseudo. In this situation, we have another observer B, but this observer B is now cycling. We can divide all the frame of references into two categories. Let's say this is this person, the lift is going upwards with an acceleration A0. I have a cable car now instead of an elevator. Okay, and this cable car, let's say, is going like this. Hello students, welcome in today's class. In today's class, we are going to talk about pseudo force. Now, pseudo force is a very interesting and a peculiar topic of physics, and I will try to make you understand this as much as possible and also take some basic numericals that will include the concept of pseudo force. Alright, so I think we can start. The first thing that when we talk about pseudo force should come to your mind is the meaning of the word pseudo. So pseudo is something which is false, which is non-existent. So that gives you an idea that this is not a force that you would normally think of which actually exists. This is a false force. This force does not exist. This is something that we are creating for ourselves, for our own convenience. Let's understand how by taking this example. So we have a 3 kilogram block here, as you can see, and this is an observer A, and this observer A is going to draw the free body diagram of this 3 kilogram block because he knows physics. So what would he say? So he would say that the force acting on the 3 kilogram block is 3g downwards because of gravity, and then there will be a normal contact force, and since this block is at rest, so he would also draw the corresponding acceleration diagram, which is going to be 0 in the y-axis as well as 0 in the x-axis, as you would know. So this is the free body diagram and this is the acceleration diagram. What would he write in the y direction? Since there are forces only acting in the y direction, this is a condition of balanced force, and we can write n minus 3g is equal to 0 because there is no acceleration, the block is at rest. So n is equals to 3g. If we take g as 10, then the normal contact is 30 Newton. So this is a very basic question that you understand, there is no problem. Now look at this situation. In this situation, we have another observer B, but this observer B is now cycling and also accelerating at the same time at the rate of 2 meters per second square. Now imagine if this person is drawing the free body diagram of this block this time. What would you say, or what would he say rather? That 3g is the force acting downward, n is the force acting upwards. What about the acceleration diagram? Now this is the problem, because you do understand that motion is a relative term. What is it? Motion is a relative term. So if motion is a relative term, that means for this particular person, the acceleration can be different for the 3 kilogram block as compared to the person A. So this person B, when it is cycling and accelerating to the right with 2 meters per second square, would obviously see the block coming towards the left with 2 meters per second square. So just think of it like this, that when he will draw the free body the acceleration diagram, there will be an acceleration of 2 in the leftward direction, and in the y direction there is going to be no acceleration whatsoever. So when he will write the force equation, so first let's do it in the y direction. In the y direction, so there is no problem whatsoever. N minus 3g is 0 because he is not seeing the block moving up or down. So n is equals to 3g, no problems here. But now when we talk about the x direction, look at it. You would say there is no force. Why are you writing equation of x direction? But there is an acceleration for this observer B. So now you are in in a confusion that what to do, because there is an acceleration that you can clearly see that this person B would be observing for the 3 kilogram block, but there is no corresponding force. So how do you write the equation net force is equals to ma? So that it somehow feels that this equation is failing here. That is what it is about. That is what pseudo force is about, that we can divide all the frame of references into two categories. First is accelerating frame of reference, and the second is non-accelerating frame of reference. All right. So accelerating and non-accelerating. We also call these as inertial frame of reference, while we call these as non-inertial frame of reference. All right. What can we say here? What can we say? That this person B, who comes under this category and who comes under this category. So A comes under this category and B comes under this category. So for A, there was no problem. Newton's laws were being obeyed. But for B, it looks like a big problem. Newton's laws are failing. Net force is not equal to ma here, because he can clearly see the acceleration of the 3 kilogram block is 2 meter per second square towards the left. What do we do then? Then we start applying a pseudo force. Now we start applying a pseudo force. So how much should that force be to justify this 2 meter per second square? Think about it. You would say, okay, the mass of the block is 3 kilogram and acceleration is 2. So the force is ma, that is 3 times 2, that is 6 Newton. So to justify this acceleration, a force of 6 Newton has to be applied. This false force. So this is a thing that you have to understand, because you are moving, things are moving towards for you in the opposite direction. So you will have to say that, you know, there is some force which is moving them, but it's not actually they are not moving, you are moving. So that is the cause of confusion. So we start applying an imaginary force just to justify that. That is called pseudo force. What is eventually the result? How much the pseudo force should be? I'm writing it here. So pseudo force, keep that in mind, will be, pseudo force will be, I'll use a different color here, let's say, okay, pseudo force is equal to, think about it, mass of the system into acceleration of the frame of reference, and then we put a negative sign. Now why do we put a negative sign here? Why do we put a negative sign here? That's because this is the acceleration of the frame of reference. So if the cyclist, if the person B is accelerating towards the right, he needs to justify the acceleration of the block in the left direction. So the pseudo force always acts in the negative direction of the acceleration of the frame of reference. So look at it again, because this is the main thing of today's class, that to justify Newton's laws, I'm repeating that again, to justify Newton's laws for such frame of reference which are accelerating, a false force needs to be applied, that is called pseudo force. And how much is that? Mass of the system times acceleration of the frame of reference, and the direction should always be the opposite, because wherever the frame of reference is going, the system will go in the opposite direction with respect to the frame of reference. Just write this and then we move forward. All right. Again, let's take one more example which you can clearly relate with. You have seen such situation where, you know, a person is in an elevator and, you know, we have to calculate the weight that the weighing machine would be showing. So let's say this is this person, the lift is going upwards with an acceleration a0, and let's say this person mass is m. What would you write? You would say mg is acting in the downward direction and n is acting in the upward direction. So this is what person A would say. Who's person A? A person on the ground, person standing on the ground. What would he say? N minus mg, n upward, mg downward. You do understand weighing machine measure the value of n only. is equals to mass into acceleration, because for this person A, the lift is going upward. This is how we used to deal with such questions. And the value of n turns out to be mg plus ma naught. The value of n turns out to be mg plus ma naught. This is how A would explain that apparently the weight of the person will be greater than mg, right? The apparent weight will be greater than mg. But this is for person A. What about person B, who is in the lift itself with the person whose weight is being measured? Would he see the person accelerating? The answer is no, because they are both in the lift. So there is no need of acceleration. So what happens with respect to B now? So this was with respect to A, now with respect to B. So B is in the lift is accelerating. Is it not a non-inertial frame or an accelerating frame? Of course, yes. So when he will draw the free body diagram, I am drawing it separately here. So mg will act in the downward direction, n will act in the upward direction, but acceleration for this is going to be 0. But what is the new force that we have to add now? So you would say that's the pseudo force. Which direction should pseudo force act? If person B is going upwards, then the pseudo force has to act downwards. All right. And how much? Mass of the system into acceleration of the frame of reference, and the direction should be opposite. So what would he write? Because for him there is no acceleration. So what would he write? N minus mg minus ma naught is equals to 0, or n is equals to mg plus ma naught. Are we getting the same answer? Answer is yes. But only when you apply this pseudo force, because this person B is an example of accelerating frame of reference, because he is also accelerating with the lift. So we tend to use pseudo force when we have situation like this, when something is kept in a frame of reference which is accelerating, and we tend to see that system from that frame of reference. You will understand what I am saying. But one thing that you can clearly understand, that pseudo force is only giving you an alternate approach. So it is not that if someone doesn't know the concept of pseudo force, won't be able to do this. It is nothing like that. You can still do the problem, but sometimes pseudo force provides you an alternate solution which is much easier. All right, we'll take that example as well. All right, first I will wait and you can copy this down, then we move forward. Okay, that means you pause the video and copy it down. All right, so next let's think of it like this. I have a cable car now instead of an elevator. Okay, and this cable car, let's say, is going like this. So it has an acceleration in the left direction, let's say 40, and in the y direction it is, let's say, 2. So this cable car has an acceleration of, can you understand, minus 40 I cap plus 2 j cap, minus 40 I cap plus 2 j cap. All right, what do you expect to happen? Because the x direction acceleration is increasing, this block is there in the cable car, but let's say there is obviously a limited friction. So let's say the mu value is 0.5, the coefficient of friction value is 0.5. Now my question to you is very simple here. I will write it here. Find the time. All right, find the time when the block will start slipping. All right, so since it is accelerating continuously, when will the block start slipping in the cable car, on the floor of the cable car? So when I talk about the solution of this now, I will do it rather with the help of pseudo force. So imagine this is the block. Okay, I'm drawing the free body diagram. Imagine what are the forces acting on this. Mass of the block is, again, let's take it as 3 kilogram itself. Okay, so what is the first force that you would apply? That's, let's say, 3g in the downward direction. The second force is the normal contact. Of course, there's no problem. But now since there are two acceleration and I am visualizing whole thing from the cable car, I am visualizing the entire thing from the cable car. So there will be two components of pseudo force. What are the two components? Since cable car is going upwards, there is a pseudo force of 3 times 2 in the downward direction. Can you understand why? Mass of the system into acceleration of the frame of reference. So 3 times 2. Similarly, if the cable car is going accelerating to the left, there is a pseudo force to the right. And how much is that? 3 times 40. 3 times 40, because the acceleration is 40 here. So the pseudo force is here. Now you can understand that friction is not yet applied, and I always say that for friction is the last force in the free body diagram. Friction is the last force in the free body diagram. So it has a tendency to go towards the right. So the frictional force will act towards the left. Frictional force will act towards the left. So imagine if this cable car becomes very fast, then the block will shift towards the right or towards the left? You would say towards the right. That explains how pseudo force is working. Pseudo force is wanting to push it to the right. There's no force like that. It's just an illusion. So with respect to the cable car, it's wanting to shift to the right. You can call it inertia also. Okay. So now you know that, friction is wanting to stop it from slipping towards the right. When will it start slipping? So we will say when this force 12T becomes greater than equal to the limiting value of friction. When this 12T force becomes greater than equal to the limiting value. And what is the limiting value? That is mu n. Mu is 0.5, and how much is n? So this is 30 and this is 6. So that's like 36. That's like 36. Alright. So I'm writing n is equals to 36. You obviously do know that friction's limiting value is mu n. So this cancels out, and t becomes, this is 1 by 2 and this is like 3. So 3 by 2. So this is like 1.5 seconds. So just at 1.5 seconds, it will start to slip. Just beyond that, just as we cross 1.5 seconds, this block will start slipping. So it was much easier to see this question, to see this situation when you were located inside the cable car itself, because then you were just seeing the block to be at rest. That is where we would normally incorporate the concept of pseudo force when we are wanting to see things from the frame of reference itself, the system frame of reference itself. You can copy this down. Now, next, what is the next thing? This is a very common question you must have seen. The question is, with what acceleration the wedge should be moved? The wedge should be moved. Should be moved. All right. So that the block does not slip on the wedge. Does not slip on the wedge. So I am framing the question right in front of you on the, so that you are able to understand what exactly I am wanting here. So this is a wedge and there is a block located on it, and we want the wedge, the block to not slip on the wedge. You would say that it might just not slip because there's friction, but the answer is that now you have to consider a situation when this wedge is smooth. So if it is smooth, how can this not slip? This has to slip. The component of gravity will obviously make it slip down. But there is a catch. What is the catch? I'll remove it from here. I will write it separately here that this surface is smooth. All right. This surface is smooth. The wedge surface is smooth. All right. So imagine you accelerate the whole system to the right with some acceleration. Let's call it A naught, or let's call it A. Okay. So what are we doing here? We are accelerating it to the right with A. The whole system we are accelerating to the right. Now imagine what will happen if we accelerate it to the right. So let's draw the free body diagram very quickly here. So obviously you do understand the components of gravity is mg sine theta here and mg cos theta here. But since you are accelerating it to the right, the whole system, there will be an entry of pseudo force, let's say there will be an entry of pseudo force. How much? M into A. All right, M into A. So are you understanding from where are we seeing this? We are seeing it from the wedge itself. So we are sitting on the wedge, let's say, and looking at the block, because if we are sitting on the wedge, the block is not moving with respect to us. Maybe for a person on the ground, the block is moving, but if we are on the wedge itself, the wedge is with the block is with us, it's not moving. But a pseudo force needs to be applied, because then we are accelerating it towards the right. So now understand, let's do the components of it. So this component would be ma cos theta, and this component would be ma sin theta, and this is like n. So I've completed the free body diagram. These forces, the new forces, are because of the pseudo force. All right, and we don't want the block to slip down or go up the incline. When will that happen? So you would say that will happen only if ma cos theta becomes equal to mg sin theta, because ma cos theta is wanting to take it up the incline, mg sin theta is of course acting down the incline. So A will be equal to g tan theta. How simply you get this answer? A is equals to g tan theta. That is your answer. That is the acceleration you need towards the right, so that this block does not slip up or down on the wedge. But at the same time, you can also calculate the value of normal reaction if you just want to. So what you can do for that? Now n will be equal to ma sin theta plus mg cos theta. Now what is the value of A? So you would write that is g sin theta, g tan theta. So this becomes g sin squared theta over cos theta. Are you understanding what I am doing? I have put the value of A is equals to g tan theta, and tan theta can be written as sin theta divided by cos theta. So this becomes sin squared theta over cos theta, and this is like mg cos theta. Now if we take the LCM, then n becomes mg common sin squared theta plus cos squared theta over cos theta. And what is sin square theta plus cos square theta? Of course it is 1. Then n becomes mg upon cos theta, mg upon cos theta, or you may also write mg sec theta, mg sec theta. All right, so that's the value of n. How were you able to do it? Very easily, because you were wanting the block to stay with the wedge, so you rather visualize the whole scenario by sitting on the wedge itself, because then the block will be at rest with respect to you. So that is how we are using pseudo force to solve the problems, by always getting onto that frame of reference itself, on that system itself, so that we can see that particular system to be at rest, and we can apply the equation net force 0. But for that an extra force is to be applied. That is what pseudo force is all about. I hope you were able to understand the basics of pseudo force. This is not a force like other forces like friction, normal contact, tension. This is not a force. This is a force that is to be applied by us just to make Newton's laws valid. All right, so that was my effort. We'll keep continuing with coming up with such classes where we are discussing some important topics that normally create problems for the students, and we hope that you will be able to learn with us. But that's all for today. Happy learning. Bye bye.
If you enjoyed this video, please don't forget to like, share and subscribe to our channel.